Good afternoon, everybody. Jeff, thanks for the kind words. Appreciate it. Thanks to the Islamic Society for the invitation. This is really a privilege, and thanks to Arun who stayed at it, won't let it go. Arun, I did try to ask my CEO to come and give a talk, like Matthias said this morning. He was too busy, so I ended up coming here. So you got what you asked for. So my talk is going to be a little bit different than what most of the ones you have heard so far. It does have some technical contents. I'm a chemist by training, as Jeff mentioned, and is in the bio. So I have a slide or two at the end, the work which I actually did about 35 years ago. That was my first assignment when I joined Xerox, almost 40 years ago. I've been hearing in the hallways now during the breaks and also the last night at the celebration at NAS. What is Xerox doing with a glass? Is that the platen where you put the paper? Is that the glass? Or is there anything else, beyond that? And I'm going to tell you that yes, we do use that. We use a good glass, transparent, which doesn't contaminate up the latent image. But that is not the end of it. The message I'm going to give you at the end is that without these photoactive chalcodonide glasses, we probably have a different corporation, not Xerox. Therefore, the reason the foundational role of non-oxide glass to enable electrophotographic printing and creation of Xerox Corporation. Notice that I didn't say xerographic printing. There is a reason, because the process actually is electrophotographic, because you move electrons and holes up and down to create the latent image. And for a long time, actually, since we got in the business, and the competitors also, everybody kept saying Xerox copy. And so there was some legal issues, monopoly part, which comes with the territory when you are making money. So the process really is electrophotographic. So you basically have a conductive substrate, a platen. You put a then photoactive material on it, put your paper on it, the document, and shine the light, and that's how you create a latent image. Then it goes through the stages. So I have a slide which I'll just teach and preach how the xerographic process works. So what I'm going to do is basically, during the next 15 minutes or so, introduce the corporation, what it's gone through to be what it was and what it is today, and then a couple of slides on the specific role of the chalcodonide glasses in the marking system, sort of the evolution from very early on to where we are, and the reasons why we are not using chalcodonide glasses. We're using a more organic based rather than what we started with, business started with. And then if there's time, then I'll have a couple slides on the work which I did on some of the chemical processes to generate these particles, reclaim tailored electrical properties of these materials. But that's my personal work, and I think out of the number we said 20 patents, 24 or 20 patents on that couple of processes there. So looks like a very complicated slide, but it's a very simple process. You walk to a machine, there's a green button, press it, and you will see the light, a flash, that's what your glass is, and then it'll hum, and the toner comes in, that's the cloud over there, up there. And then, and then it goes through fuse and fix. So that's why when you get a copy, it's warm. And by the way, that's why you cannot write on it because there's oil on it. So press the button. If you're lucky, you'll get a nice color print. If you are not, then maybe you will be in the paper jam down there. Where's that pointer? There. This is a real pic from the lab. Oh, by the way, this was not a Xerox printer, so that's the cartoon, this one shows how the whole, I've shown only these three key steps, but if you heard the other talks on xerographic process, there are 6 steps. So other 3 are buried in between these 2, but these are 3 key ones. That's where you have the role of these glasses in this process. So you can actually do it on a single pass. You can do it on a multi-pass. Because single multi-pass means if you just want to make a black copy, and then you can do it on a paper, you can do it on a photo subcontainer transfer, or you can do it on a belt and transfer. The multi-passes are basically when you make the color images. So you are putting all these 4 primaries in a systematic way to make the image, and then transfer either in a one go, or you can keep doing like down here. This is a long belt, it's called intermediate belt, but you're printing on those, and then you transfer to the paper and fix down here. So this is a simple, it looks like complicated, but there are a number of technologies which are buried in this, and Xerox has keep playing in it, competitors play in it. Our Fuji counterpart over the years have commercialized this technology, which also it was invented here in Webster, but transferred because Fuji is a business partner. And the other competitors do the same things also. Okay, so now a little history, where we were, a invention to then finding a partner, bumping around, and then finally Xerox Corporation. So if you come to Xerox and in the lobbies, in the building lobbies, you will see let's go back. Okay, this is the Astoria. You will see the pictures of that, historic. So it was Chester Carlson right there, who was an engineer, and then his associate Otto. They are the one who made the first print. That's why this Astoria is the one which they did on a desktop, just in the lab, curiosity-wise. And the way they did was that they had a conductor plate, which is zinc basically. They had a sulfur coating on it. They wrote this Astoria, the October 22nd, 38 on it, shined the light on it, and then they were able to transfer to a plastic sheet. And that's how the first xerographic print was made. And the rest, this was done on sulfur, by the way, but the concept This is the concept demonstration. And the reason why, this is why it's called a xerography, because this is from Greece, Xerox, dry graphic writing. This is true that this is what started, and the Xerox Corporation is the result of that. So that was 1938, and you see that they filed a patent. The ones who was the Shark Tank, first thing they say, oh, you have a cute idea, but do you have intellectual property? So they did file, and see the gap between, gap between 39 and 47. This is how long they played with a cute idea to keep optimizing. And obviously they went around and, from anybody who can help them, money, infrastructure. This is like any startup as it goes through. Nobody will pay attention, obviously. And then Halide, which was in Rochester, that became Xerox afterwards. Halide is the one which they said, okay, we'll look at commercializing it. We'll develop the idea. And as we all know, that it's one thing to have an idea and then to take it from stepwise all the way from test tube to the customer hand. There are a lot of values of that in there. You need infrastructure, you need money, you need talent, on and on and on and on. So they realized very fast that they are not going to be able to do it themselves. So they went around, IBM, GE, Kodak GE, for, they didn't even give them a time of the day. IBM at the end said that, okay, we'll look at it, we'll evaluate it. So IBM then contacted the auto dealer, come back with evaluation and practicality of this product. So you can see what they came up with. That it is a cute idea, it's only very specialized application, no good. And now Joe Wilson, who was a leader at Halide, he decided to actually bet the company on this. They developed a product, and this is our first product, first copier. And again, along with the story, if you ever come to Xerox, you can see this machine and the team behind who actually came up with a lot on our walls and all that. Very proud moment, 9/14. And you can see the time, by the way, between getting the feedback from 80 Little, 50s, another 9 years before the launch. And then, but that was the start. Then after that, you can see from 59 to 72, it sold, the sale went from 30 million to 2.5 billion in 30 years. That was remarkable. And the question, and it became Xerox, from Halide to Xerox. And question is always is that having an idea is one thing, but do you have a business model? And how is it that a consultant like A.D. Little went wrong? What is that they didn't consider in all this? What they did was they used actually the traditional model. And what was there at that, it was a vet, template-based, ink-based, And all that you will see here that it's a thermal process, messy, low quality, it's cheap, $300 a machine. It doesn't need special inks and papers and supplies because ink cannot write on every paper. You know, so you have to worry about where you're putting it and its stability over time. Once you make a template, then all the average output was 15, 20 copies per day, but customers were not using more than that, simply because it's dirty and filthy and all that. But it did have it did have the infrastructure and the serviceability of the equipment, because that was a running business. On the other side, Xerox product, it was dry, toner-based. Quality was very high. Again, if we look at the quality of the 914 and if you look at the quality today, it's miles difference. But it was much better than the current. And the equipment was, $300 versus $2,000. It's a lot of investment for small businesses. And this goes back in 50s and speed was 7 copies per minute. Nowadays we are at 300 copies per minute in most of our. The bottom line is different model was used, and therefore the reason why 80 littles. What's that smart Joe Wilson did then? How did he? And you can see that he came up with this leasing model. He said that, $95 per month to lease the machine. I'll give you 2,000 copies per month free. After that, you pay 4 cents per copy. And we will provide you all the service, all the materials and everything. Oh, by the way, if you're not happy, call us, give us 15-day notice, we'll come pick it up. So that lowered the barrier and for the customer, and Xerox bore the risk. And look at the number, enormous usage, average greater than 2,000 copies per day per machine, as you saw. You can see that model, how well that works. Again, this is basically saying what I was saying before because of time. So chalcogenize from sulfur, we went to alloys, of course selenium to start with, then selenium, thorium at different levels, percentage in between. And these are all the versions of chalcogenides. And AMAT down here is then you disperse trigonal selenium, precipitate trigonal selenium in a matrix. That's what you use at charge generation, charge moving. And the slide is available, so for folks who cannot see at the back there. So these are actually the products which we put out with the chalcogenides. So therefore, the reason in the process, this slide is from Henry Chesbrough, my friend at Berkeley. We made a lot of other people very, very rich. There are a lot of, there are books on it. But 4 decades, there are names, there are dates, there are who, what percent is Xerox on, what percent the others on. By the way, some of these became the NA members in that category who moved out from PARC and went over and started their own businesses. I can stop here, Jeff, if you think. Yeah.
Have closing remarks.
So in closing, you could see that without the chalcogenides, we probably will be doing something different than what we're doing today. company has gone both up and down. The new way people are printing, the xerographic printing has been challenged during the past 6, 7, 8 years. People don't print that much. I mean, the kids just look at the phone and look at only the folks who want to carry something in their hand. They want. The focus now is on actually inkjet printing. And this piece of pie, which is very, packaging, our transactional printing is the one which everybody is behind. The oxide-based glasses also play a very key role in inkjet printing. There is a PZT we use in our print head, lead. We have a very active effort in removing it. Anybody can help with that. We are actually working with Brown on replacing the lead. So that's one opportunity. In our 3D, because it's fair game for us that making it a print is a 2D, what is stopping us keep building on and on. So that's a 3D. And we have a metal 3D printing technology which we acquired. It's a wire fed, and we've been working with, we have been to Alfred for some help for high temperature material for the nozzle and the reservoir. With that, thank you again for inviting. This was a pleasure. Thank you.